Right, welcome back. We're continuing with our question, but now we're focusing on part B. Please check the previous video, the one on top there. Yes, then you're going to see how we solved part A. Right, so want to prove the suggested nth derivative by induction. So what are we given? We're given that minus 3 to the power n factorial over 3x plus 1 to the power n plus 1. So this is our nth derivative, right? So in short, this is the same as what is dy to the power n over dnx, right? So we're going to follow this following steps. Maybe let's just rearrange. We have dy to the power n over, well, I'm just rearranging the whole thing so that I have the normal left hand side and the normal right hand side. Yeah, 3x plus 1 to the power n plus 1. So we're going to use the previous answers so that we don't repeat the same answer, same thing. So you consider the left hand side. Consider the left hand side. Left hand side when n equal 1. So when n equal 1, the left hand side, it means that it will just be what? Dy dx. That's why I said we need to what? We need to consider the previous answers. What was our answer for dy dx? Our answer for dy dx was minus 3 over 3x plus 1 to the power 2. Please check the previous video so that you are not lost. That was our dy dx. Right, so next we consider the what? The right hand side. Again, when n is 1. The right hand side, we're considering, it means that wherever there is n, we're replacing with what? With 1. 1 factorial over 3x plus 1 to the power 1 plus 1, which is, we know that minus 3 to the power 1 times 1 factorial is the same as minus 3 over 3x plus 1 to the power 2. We know that 1 plus 1 is what? 2. So what does it mean? Therefore, the left hand side is equals to the right hand side, which implies the statement is true when n is equals to 1. Right. Okay, next, when n, yeah, so next is the assumption stage. Assume true for n equal k. So for n equal k, it means that wherever there is n, we replace it with what? With k. So it means that dy to the power k over dk x is equals to what? Minus 3 to the power k factorial over 3x plus 1 to the power k plus 1. Let me just check if that's the given form. Yes, that's it. Right. Then when n equal k plus 1. Right. So the right hand side, what's the right hand side? The right hand side equal means that we go to the right hand side, wherever there is n, we replace it with what? With k plus 1. So it's minus 3 to the power k plus 1 factorial over 3x plus 1 to the power k plus 1 plus 1, which is k plus 2. Right. Next, what happens is we want to prove that this statement is also true when n is on the left hand side. So consider the left hand side. So in the left hand side we have what? We have dy, but now it's dy k plus 1 over dk plus 1x. So we can separate this into two. This is the same as dx dy over dx. Okay. So the other one. So this part we're going to have our k here. Right. So it's like we have utilized indices. We know that x to the power y plus 1 is the same as x to the power y dot x to the power 1. So that's what we've done here. So now what are we differentiating? We're differentiating the assumption stage. So it means that we're saying d dx open bracket minus 3 to the power k, because we already have that in the assumption stage, k factorial over 3x plus 1 to the power k plus 1. So I want you to note this. As you are differentiating here, there are constants. Minus 3 to the power k plus 1 factorial is a constant. So note that. So let's just separate it in this form so that so this is the same as minus 3 to the power k factorial, right? Then differentiating what? 1 over 3x plus 1. Because remember, we're differentiating with respect to k. That is with respect to x. That is why we're saying that numbers that do not have any x in this case are what? Are constants. Right. So this is the same as before we differentiate, we are further separating our question, which is the same as dx 3x plus 1 to the power minus k minus 1. Yes. Right. So now it's time for us to differentiate. Remember, we said that minus 3 to the power k factorial are what? Are constants, right? So we bring down the power as usual. Minus k minus 1. We differentiate what is inside the bracket, which is 3x plus 1. So it's 3. Then the power reduced by 1. So now it's 3x plus 1 will come back as it is, minus k minus 2. So let's write our answer neatly. So to make our answer neat, this is the same as, okay, let's do it one step at a time. Minus 3 to the power k factorial minus k minus 1, 3, everything over 3x plus 1 to the power k plus 2. Yes, we're almost there. We're almost there. Because remember, our answer should look like the what? The assumption stage. That's the goal. Our answer should look like the assumption stage. Right. So next, what are we going to do? So what we'll do next is we're going to group our terms. This is what we'll do. So minus 3 to the power k factorial, right? So I want to migrate. I want to factorize, right? In minus k minus 1, I want to factorize this minus 1 so that I have minus 1, then k plus 1, and what? And positive 3. And then the next thing that I want to do is I want to migrate that minus 1 such that it multiplies with that positive 3. So that minus 1 is going to migrate, and then we have this minus 3 to the power k. So far, we are not disturbing it, and this k factorial. We're still dealing with this stage. We're still dealing with this. Yes. Yeah, you know that in maths, a to the power 0 is 1, right? And 1 to the power 1 is 1. So there are many ways to represent the same thing in different ways, but you have to make sure that you are representing it in a way that is convenient for you to get to move quickly to the answer. So minus 1 times 3 is what? Is minus 3, open bracket, k plus 1. Do you see what we did there? Now, you want to group. We're almost near the answer, guys. I'm getting excited. We're almost near the answer. We're getting there. 3x plus 1 to the power k plus 2. Right, so minus 3 and that minus 3, they're alike. They have something in common. Because remember, these things are just separated by, we have invisible times there. So we can move them anyhow. Remember that 2 times 3 is the same as 3 times 2. So you just move it in a way that it's convenient for you. So I am going to move that minus 3 and make sure that it's very closer to minus 3 to the power k. Okay? Then I'm going to start by writing k plus 1 k factorial. You are going to see why I did that. We're almost there. We're almost there. You don't give up. You don't give up, guys. That's the key with the maths. Right. So minus 3 is an invisible power there. Power 1. Okay. So this is the same as what? Minus 3 to the power k plus 1. Do you see what we wanted to do there? Of which, what do we know? We know that k plus 1 factorial. K plus 1 factorial is the same as, maybe let me just write it here so that let me use another color and make it a bit small. Right. Yeah. Recall, I'm going to write it here in blue. Recall that k plus 1 factorial is the same as k plus 1 k factorial. You can try it using numbers. We're saying that 5 factorial is the same as 5 factorial times 4 factorial. Yes. I think there's a video. I'm going to pin it also over there so that you practice on these factorial things. They're very interesting and actually nice to play with. Right. So we're going to replace k plus 1 k factorial by what? By k plus 1. Do you see the trick? Yes, that's the trick. Going to replace it with what? With k plus 1 factorial over 3x plus 1 to the power k plus 2. Why are we doing this? We're doing this such that this stage, this one, right, is exactly the same as the right hand side. Once you have done that, it means that we have reached the goal. We are done. So then you comment. Since the left hand side is equals to the right hand side, therefore the statement is true when n is equals to k plus 1. Then now that you write the final statement, therefore the statement is true for all n k belonging to a set of what? Real numbers or natural numbers. It depends with what the question was saying. But yes, you have to have that final conclusion. Yes, the end. Let us meet in the next video. Please don't forget to comment, like, and subscribe. Have a lovely day. Thank you.